Let's go through it. Let's go through it step by step. Day by day. Picture time. Just take a look into the notebook. All right. Anytime we're doing double angles, we have to find cosine 2 alpha first. In other words, the double angle of cosine. Well, in order to do that, I need to use the sine squared plus cosine squared equals 1, where you just move stuff around to come up with cosine equals square root of 1 minus sine squared. Well, that means that cosine 2 alpha is going to equal sine, or square root of 1 minus sine squared 2 alpha. But I just replace square root of 3 over 2 there. Work it down. It comes to 1/2. I thought you guys had the answer.
Yeah, no, I skipped the middle step.
Oh. Okay.
Because you said it could be a two-step answer. It's like, oh, then that was easy. But I want to make sure I have everything done.
Okay, gotcha. All right. So then I have 1/2. This is the step that we could potentially skip, and I'll show you how down below. But just for the flow of the problem, because we usually have to find cosine and sine, once I know cosine of 2 alpha equals 1/2, I plug it into this equation. Cosine alpha equals square root of cosine 2 alpha plus 1 over 2. I told you to write that down on your sheet because it's one that you're going to use probably a lot. And when I plug that 1/2 in, multiply top and bottom by 2 and 2, I get 3 over 4, which reduces to square root of 3 over 2. 4, 2, 2. Square root of 3 over 2. Then I just plug it into the sine equals square root of 1 minus cosine squared. Reduce that, it turns into a positive 1/2. I do know it's a positive 1/2 because it says that 2 alpha is in quadrant 1. Let's take a second to think about what that means, because they didn't give me anything I can multiply by 2 or divide by 2 to figure out where it is. This is saying if I have an angle and I multiply it by 2, it's in quadrant 1. I'll say that one more time. This is saying that if I take an angle, multiply it by 2, it is still in quadrant 1. So it'd be like if my angle was 30 degrees, the double angle would be 60 degrees. In order for 2 times my angle to be in quadrant 1, the biggest angle it could be would be 89.9999999999999 degrees. But if I divide that in half to get my original angle, it is still in quadrant 1. So if our double angle is in quadrant 1, the original angle must also be in quadrant 1. So it must be a positive 1/2 because we're in quadrant 1. Any questions on this problem? We're okay? Did you see where you made a mistake or something?
I just didn't finish.
Yeah.
Oh, okay.
I was on the last step.
Okay. So I'm going to start the lesson and we'll go over questions. So the lesson is really that short. It's just these bottom 2. And it is just the question, basically, why did Mr. Pabian say I have to find cosine 2 alpha first every time we're doing double angles? So the very first day, we kind of took it by faith because we didn't have a full understanding of where these equations go, how to use them. But I feel like we have a good understanding of how these equations work. So now we're going to talk about why I told you the very first day, if you're looking for a double angle, you always have to find cosine 2 alpha. And we're going to figure out why by first pretending like I don't know that information. We're going to try breaking it and just starting with sine of 2 alpha equals square root of 3 over 2 and not finding cosine 2 alpha and see if we can find the answer that way. So on the left-hand side, we're going to pretend like Mr. Pabian never told us to find the cosine 2 alpha first. And we're going to try to solve that bell work question above without using it. So the bell work was sine of, I'm going to change it to 2x because x is a lot easier to write than alpha all the time. And that was equal to, correct me if I'm wrong, but I had square root of 3 over 2. Is that what we had in the bell work?
You're right.
Cool. So now I'm pretending I'm not going through cosine 2 alpha. So all I know is sine 2x. Well, I go to my identity sheet that I'm allowed to use on the test, and I say, okay, sine of 2x. I have an identity for that, so I can rewrite sine of 2x, and I can rewrite that as 2 times sine of x times cosine of x. All right. Well, the thing is, I know that sine of 2x equals square root of 3 over 2. Big mistake alert that I saw yesterday. I saw people just throwing it in for the 2x. You can't do that because it actually says this entire quantity equals square root of 3 over 2. So you're going to replace the entire sine of 2x with square root of 3 over 2. So well, that equals square root of 3 over 2. That's going to equal 2 times sine of x cosine of x. The only thing I could do to simplify this any further is divide both sides by 2. Which is going to turn into square root of 3 over 4 equals sine of x cosine of x. Does that look simpler?
No.
Thanks for covering. No. Do I know what sine of x equals because of that?
No.
Do I know what cosine of x equals because of that?
No.
All I know is sine times cosine equals square root of 3 over 2. So all I could really do is just guess at two possible values that work there. But you probably don't want to guess on a test and hope you're right. So this right here is the reason that if I have sine of 2x, I can't just plug it into a double angle formula because I'm left with sine x and cosine x. And that's why this method we cannot do. If I ever tried to do this formula I got here, it tells me I can't go any further unless I know what cosine x is or if I know what sine of x was. But if I know either one of those values, I'm pretty much done with the problem anyway, and I probably won't use this equation. So on the right-hand side, now we'll go with, hey, I figured out that cosine 2 alpha was 1/2. So that's what we're going to do in this box, that cosine 2 alpha equals 1/2. X equals 1/2. Now let's say we don't have, remember I had you write down that extra formula next to it? Let's say you didn't have it, didn't write it down, you forgot your identity sheet, and you had to borrow one that didn't have it written down. Well, you can just say to yourself, well, cosine 2x from my identity sheet, which I didn't write this one down, this one came preloaded on there, is the same thing as 2 times cosine squared x minus 1. Once again, since I know that cosine 2x equals 1/2, I can replace cosine 2x with 1/2. So that's going to give me 1/2 equals 2 times cosine squared x minus 1. Now I'm just going to solve for cosine x. So that means I'm going to add 1 to both sides. 1/2 plus 1 is going to be 3 over 2 equals 2 times cosine squared x. Divide both sides by 2. That's going to give me 3 over 4 equals cosine squared x. Take the square root of both sides, and you're going to have cosine x equals square root of 3 over 2. And that's the exact answer you got in that middle column. That's all we really did in that middle column, is we very sneakily, because I adjusted the formula just to go right towards the answer, but we very sneakily did everything that happened here, but we put it all in one location. Because if you look at this, I add 1, divide by 2, and take a square root. Well, that's everything we did here. I added 1, I divided by 2, and I took a square root. Now, why it's important to see that? The bell work could have been done in 2 steps. You could have found, you always have to find your cosine of 2 alpha equals 1/2. However, if everyone looks at their identity sheet, there are 3 ways to rewrite cosine 2x. One method is 2 times cosine squared x minus 1, which will result in cosine x equals a number. Another one is 1 minus sine squared x. If I would have put cosine 2x equals 1 minus 2 times sine squared x, and worked it out, I would have actually had sine x equals 1/2 right here. So you can use other formulas. Yeah?
Oh, wait. But how do you do that?
Let's pretend like we didn't do this. Hopefully you have this all written down. Let's say I was really smart, and I really understood these identities really well. I would have been able to say, well, cosine of 2x, since I didn't ask for cosine, right? I just asked for sine. In the bell work, I just said, what is the sine? So you could have said, hey, this equals 1 minus 2 times sine squared x. That's one of our identities on the identity sheet. And if I would have plugged 1/2 in for this, I would have actually worked my way down, and this would have came out to sine of x equals 1/2 if you did all the math. So that is possible. If you're slightly confused at what I'm saying, do the normal, because most of the time I ask for cosine and sine anyway. Just find cosine 2 alpha, find cosine, then find sine. No problem in that. All right? Any questions? But this is why we have to find cosine 2 alpha first if we're doing double angles. All right, that being said, what questions do we have from yesterday's in-class / take-home homework? Yeah, Liam. I don't know that one.
Number 66.
We didn't have to do that one.
Oh, cool.
Yeah.
Number 64.
We didn't have to do that one either. No, I'm just kidding. That one we did. All right, so number 64. The big thing about this one is we do have to work on both sides. And we're going to notice that secant squared x over 2, we don't have a secant identity, so I need to change it to cosine. And we have to change something just a little bit. So let me take a picture of what I did. And then, in fact, I'm going to take a picture of my identity sheet, because that'll make it a little easier to show. Okay, so I rewrote cosine as 1 over, or I rewrote secant as 1 over cosine squared x over 2. Now, if we look at our identity sheet, I don't have any squareds there. I don't have any squareds there, and they're asking me to do cosine squared x over 2. But what I can do is if I would square this side, I would have to square the other side. So cosine squared x over 2 actually just equals 1 plus cosine x divided by 2. It gets rid of the square root by squaring both sides. And as I said, you can write on this, you can write identity. So if you wanted to, you could write cosine squared x over 2 equals 1 plus cosine x over 2 if you think that's going to help you. But that's what I replaced it with. There's no square root because it's squared. And then it's just reciprocal. It gives me 2 over 1 plus cosine x. Now I'm saying to myself, one side has cosine in it, the other side has a bunch of secants in it. So I'm going to rewrite every secant as cosine. So I changed them all to 1 over cosine. And then I said, I don't want to deal with fractions over fractions, so let's multiply by the denominator. So I multiplied the top and bottom by cosine of x, and then I distributed, which got me to 2 plus cosine x all over 1 plus 2 cosine x plus cosine squared x. Well, 1 plus 2 cosine x plus cosine squared x, in other words, 1 plus 2x plus x squared, is just screaming factor, factor, factor. And if I factored it, I would see I'd get 1 plus cosine x times 1 plus cosine x. And if I factored out a 2 out of here, I would get 2 times 1 plus cosine x on top. Gone, gone, left with 2 over 1 plus cosine of x. And you are done, and you're on the next problem.
But we didn't have to do the next problem.
Today. Fair enough. Does that make sense? Other questions? Teresa, if Jack's head's in the way, you can always sit in that one. That's all.
Or just tell me to move.
Oh, yeah. As you move back and then she has to. Alright,
Can we do 56?
sure. $56. Oh, that was that beast of one, right?
Yeah, this one's a long one.
That'll take a second to explain. And it really comes down to one really complicated step. I get that it's long, but just because a problem's long doesn't mean that it's going to be a tough problem. It just means we have to be careful as doing it. So I noticed it was we have double angles formulas. We don't have triple, we don't have quad angle, we don't have anything past that. So this is 4 times an angle. I can't do 4 times an angle, so I broke it apart into 2t plus 2t. It was like when we had that triple angle, and I broke it apart into 2t plus t. So I'm breaking this apart into 2t and 2t, and then I use the sum angle formula. And the sum angle formula for sine is sine of alpha plus beta equals sine times cosine plus cosine times sine. So that's what I did. Sine times cosine plus cosine over A, sine over B, but they're all the same. Now I have a whole bunch of double angles. Sine is easy to do. That's the first one you should look at because sine of 2t is always going to be rewritten as 2 times sine t cosine t. So my sines are easy to do. It's the cosines that give us 3 possibilities. And what's going to tell us what to do is our answer. We have one chunk, we have another chunk. If I look here, I have one chunk and another chunk of information. So one of these chunks must simplify to one of these. I don't know why, but I picked this chunk here to match this one. And this chunk says sine cubed t cosine t. So I need to create a sine cubed. In order to do that, I need to rewrite cosine 2t as 1 minus 2 sine squared t. I have to. It's the only one that's going to create that sine cubed and leave cosine as just to the power of 1. So to create my sine cubed, I pick sine squared for this one. To create this one, I rewrote it as 2 cosine squared minus 1 to give me that cosine squared, and it would leave my sine is just sine to the first. And then the rest is really just simplifying and being careful about it. Because things will cross out. You'll divide 4 on both sides, and it's going to simplify to the other side without doing anything to the other side. Liam.
Okay, so I get it up until the first, like, really long. Right?
Here?
Yeah, I don't get how you got that. You said that there is 2 chunks and then the one is like...
Okay, so let me highlight. So you see this section? I'm trying to make that section equal to that.
Okay.
Well, there's only one way to rewrite sine, so I already know that method. But I'm going to say I need to create sine cubed, and I need cosine to the first power. So for cosine 2t, I'm not going to pick the one that's cosine squared minus sine squared, because that's going to create a cosine cubed here and a sine cubed, which is a big mistake. I just need to create sine cubed, so I'm going to change that to sine squared version. Okay? Because we have the 3 choices. Does that make a little more sense?
Yeah.
Okay. And then obviously I use this one to create my cosine cubed, which means I'm going to rewrite it as the 2 times cosine squared t minus 1. All right, other questions? Yeah.
Can I see, like, so I'm on 58, can you just like go through that?
On 58, seems like people are just kind of overthinking 58. So I had a lot of questions. It was supposed to be an easy one, but it struck a lot of controversy. I think people thought it was much harder than it should have been.
Oh, what the heck?
Just do the multiplication.
That's what I did.
And it comes down to this would be sine squared plus cosine squared, which equals 1. And and then you just have to rewrite that one, and you're done.
Mm.
Do you see it now at least? Do you agree that mine's right at least?
Yeah, I get it.
Okay.
I don't know why I did what I did though.
You did what you did. Okay, other questions? Okay. Thank you, Liam, for picking a day